In today's lesson, we are going to be looking at going from a graph to a rule and from a rule to a graph. So again, the main idea that we're going to be looking at is just being able to convert between different variations or different representations of a linear pattern or a linear function. We've looked at going from a visual pattern to a rule or an equation. We've looked at going from a table to an equation. And now we're going to be making the connections of graphs and the equation. So for this example, we have our graph here, just a general graph looking at the number of tiles and the position number, and we want to form a rule that's represented by that graph. We're also going to create a table of values to help us with that. Because we've previously gone through looking at a table, this should be relatively easy once we create our table. So if I look at my graph, I can see that I have nicely laid out points. So I can easily plot those values. Again, remember x is the horizontal, y is the vertical. So there's two coordinates for each point. So 0 and 2, 1 and 4, 2 and 6, 3 and 8, 4 and 10, 5 and 12. So from this, we should be able to come up with our rule. Even if we weren't able to quite get it from the graph, we should be able to do it from the table. If not, please make sure you review the previous lesson. Again, for a rule, we want y equals mx plus b. That's the general form. Again, the m is the multiplier, the change in y over change in x. B is the constant, or the starting value, or the initial value, or the y-intercept, or when x equals 0. So right off the bat, from our equation, I can see my y-intercept, or I can see when x equals 0, y is 2. So in this case, I already know in my equation, I'm going to have a plus 2. So it would be y equals something x plus 2. So now I need to find the multiplier. I need to find what it's changing by every time. In this case, if I look at my y values, they're going up by 2. I can see that pattern changing. It's going up by 2 every time. The x values are also increasing by 1 every time, which is good. That's what we're looking for. So that means my multiplier is 2. Y equals 2x plus 2 is the equation for this linear representation that we see in this graph, as well as the table that we created. Let's take a look at another example. Again, we have nice points laid out in our pattern or on our graph. So let's go through and label them. Again, remembering x is horizontal, y is vertical. So we have 0 and 0, 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. Again, for our rule, we want y equals mx plus b as our general form. Anytime we are asked to come up with a rule, that's what the form should be. Right? M is the multiplier, change in y, change in x, b is the constant, y-intercept. Initial value, when x equals 0, the y value. So lots of different terms for those constants or those variables. We can find the b value because we can see in our table when x is 0, y is 0. So I know my equation will have a plus 0 at the end. I don't really need to show that because when I add 0, it doesn't really change anything. But for sake of argument and just showing where it would go, I'm just going to place it there. Now I need to find my m value. What is my pattern changing by every time? Well, you can see that it's going up by 2. Similar to the last one, and I'm increasing by 1 position every time. So if every 1 position I'm going up 2, that tells me that my multiplier is 2. So this works out to y equals 2x plus 0, or just y equals 2x. Either would be correct. One's just showing additional information that's not really necessary. So what is the same and what is different between the graphs? Well, we should notice they have the same multiplier. Same multiplier, right? They're always increasing by 2. What is different? One starts at 0. One starts at 2. Again, looking back over them, you could look at the table, you could look at the equation, you could look at the graph. But I think those are the two main things that are different. Right? You could talk about the relationship, one's increasing or one will have more after a certain amount, that type of thing. But the main two things that are the same, or the main thing that's the same is they have the same multiplier. You could say both lines. How are they different? The main difference, or the only difference is that one starts at 0, one starts at 2. Are there any connections that we can make between the multiplier and the table and graph? Well, we talked about the multiplier. It's what it increases by. Increases by each position number. And we talked about that. You can talk about how it's a constant amount. You talk about what the y changes by. For every one x value, or for every one x. What do we notice about the constant and the connections between the constant and the table and the graph? Right, when x equals 0, y equals the constant. So we've talked about that previously. You might also mention that it's the y-intercept, where it crosses the y-axis. Could also say where it starts. Again, that might vary depending on where or how we see our graph, but the main things, again, we see the connection between when x is 0, y is the constant. It's the y-intercept at where it crosses or touches the y-axis. So those are what we're going to be using to help us come up with the equation, focusing only on the graph. So to determine the rule from a graph, we need two things. We need m, which we're now also going to call the slope of the graph. If we looked at each of those lines, they had the same steepness, the same slope, right? And that's because they had the same multiplier or the same rate of change. So we're adding some new terminology. We can call m the slope. B is the y-intercept of our graph, which we've mentioned before. When x equals 0 in the table, the y-intercept is just basically what that term refers to when it's plotted on a graph. Again, we also know it as the constant. Oops. Little technical glitch there. We know the y-intercept for when it's on the graph. We know it as the constant and also the starting value. Right, so again, just some new terminology specific to the graph of how we can find the m and the b value. Now, slope is a new term, so we are going to learn a new kind of formula of how to look at it. So to find the slope, what we can do, or what we're going to do, is we're going to find 2 points on the graph that are on whole number values. So even though if we look at our line, it may cross between decimal points or uneven numbers or not nice numbers, we want to find where it nicely crosses the grid lines so we know the exact values of those points. From there, we're going to determine the rise or the change in y, basically how far up or down we have to go from one point to the next. And we're also going to determine the run, or the change in x, or how far left or right we have to go from one point to another. We're then going to use those two values in a new formula for our m or our multiplier, and that new formula is rise over run. This is just a play on the change in y divided by the change in x. So the same formula we used when looking at the tables, we are going to apply to graphs. We're going to use a different terminology, rise over run, but essentially it means the same thing. To find the y-intercept, we determine the value of y at the place where the line crosses the y-axis. So this is the really easiest part because we are looking for the y-intercept or that b value. So we just go down our y-axis and see where does our line cross. The value on the y-axis where it crosses is our b value, our y-intercept. So for this one, let's determine the rule or the equation. Right, we're going to avoid creating a table of values because we kind of want to streamline this. Again, y equals mx plus b is our general formula. We're looking for the m and the b value. Easiest thing to do is find your b value. We see our y-axis here, the vertical axis. And we're just going to draw a line down until we touch our line. So you see the line crosses that y-axis right there. That's our b value. In this case, our b value is -2. Next, what we're going to do is we're going to find our slope or our multiplier. Now, we are already given one nice value with this y-intercept. So I just need to find another nice point, and by that I mean where does the line neatly cross these grid lines? I can see a nice point here, so I know exactly where those values are. I see another one over here, here, up here. I even see them down below. So those are all nice points. Now, it doesn't really matter which points I use. In some cases, I may get larger numbers, but when I reduce or divide, I will get the same answer. So we'll do two different ones here just so we get an idea that it doesn't really matter which 2 points we use. So using the y-intercept and this first point up here, my run is over 1, so I go 1 in the right or to the right, which means it's a positive 1. So if we write this out, rise over run, my rise is a positive 1 because I'm going 1 in the positive direction. Or sorry, that's my run, not my rise, my run. And my rise is going up 1, 2, 3. So I go up 3, or positive 3. So my m, or my slope, is rise over run, or 3 over 1, which is equal to 3. If we wanted to do a different example, let's say we use that let's not use the y-intercept. Let's remove that y, not remove it. Let's just use a different value or 2 different points, just so we get an idea. I'm going to use this point here and this point here. So from one point to the next, I go over 1, 2. So my run is 2. My rise is 1, 2, 3, 4, 5, 6. My rise is 6, so 6 divided by 2, which reduces to 3. So it doesn't matter which 2 points you use. You can even go in reverse if you want. It would still work out. Right? You can find the rise first, you can find the run second. It still works out because you're just putting those values into an equation or into a fraction. I could start at a higher point and work down to a lower point. It'll just mean my values might be both negative in this case, but I should still get the same answer. Now that I have my m and my b value, I'm going to plug them into my equation. So y equals 3x minus 2. And that is my equation for this line. Let's take a look at another equation. Right, same idea, y equals mx plus b. I'm going to start with my b value. I'm going to go down the y-axis. Oh, I hit my point. I hit my line. I hit my line at a value of positive 3. So that's my b value. Next, I want to find some nice points to be able to find my slope. I have one nice point of the y-intercept, so I'm just going to find other nice points that I can plot. So where the line neatly crosses the grid line. You can see some here. So I have plenty of points to choose from. Again, it doesn't really matter which pair of points you use, as long as you're using 2 points on the line and you know clearly where to go from one to the next. So, just for sake of argument, I'm going to use the y-intercept because again, that is a nice point that I already know. So from here, to go to my next point, I'm going to go to the next point to the right. You could go to the point to the left. You could go to any other point. It doesn't matter, as long as you're using 2 points. So from this blue point to this first red point here, I'm just putting back in, I go over 1. So my slope formula, rise over run, I just found that my run is going to be 1. My rise, I go down now, 1, 2. So because I'm going down 2, my rise is negative 2, which makes sense because I'm going downwards. So my m, or my slope, rise over run, is equal to negative 2 over 1, which is equal to negative 2. So now I can put those two pieces together. My equation is y equals negative 2x plus 3. And this is one of the reasons why we talked about leaving fractions as improper fractions and not mixed fractions. Because if I have an improper fraction when I'm dealing with slope, that will tell me the rise and the run. If I have a mixed fraction, it won't give me a good, accurate, or won't give me a nice way to figure out the rise over run. It still will give me the multiplier, but if I'm going to graph it, it wouldn't give me a rise and a run specifically. I would have to do extra work to figure it out. So this is one of the reasons why at the beginning of the course I mentioned leaving fractions as improper fractions, not mixed. So we looked at getting an equation from a graph. We are now going to look at graphing an equation. So if I give you an equation, can we graph it? So we're going to use the y-intercept and the slope because we're given the equation, and we're going to use what we know about the y-intercept and the slope to graph the line. The first step is to plot your y-intercept. You then use the slope, or rise over run, to determine other points, and then you connect the lines, or basically connect the dots and extend. So we're just basically going in reverse. So here we have the equation y equals negative 1 over 2x plus 5. So I have two parts. I have my b value, which is the y-intercept, and I have my m value, which is my slope, or rise over run, or multiplier. So really, if you really wanted to and you didn't know how to graph it straight from the equation, you could create a table of values, plug in various values for x, position 0, position 1, 2, 3, 4, and so on, to find values for y and then graph them. But that would require more work. So we just want to learn how to go from the equation to the graph. So the first thing we mentioned, graph your y-intercept. We have plus 5, so we know our graph has to cross here at plus 5. Next, we're going to use our slope, or our rise over run. So m equals rise over run. Here we have our slope, or our m value, of negative 1 over 2. You could place the negative with either one. We talked previously in a previous lesson about negative fractions. The negative can go either with the 1 or the 2. In the end, it's not going to matter. It's just going to change the direction that we're going in our graph. So if I have negative 1 over 2, that means I go down 1 and I go over 2 in the positive direction to get another point. I continue that, go down 1 and go over 2 to my next point. I can plot a point there. Go down 1 again, to the right 2 or in the positive direction 2, and you can probably start to see the pattern and fill out the rest. Now, if I wanted to work backwards, I can switch that negative sign, put the negative on the bottom. It's not going to change anything. It's still a negative fraction, but when I go and I plot it, it gives me a different direction. So I go up 1 now, and to the right or to the left 2 for a point. I go up 1 again, to the left 2 or in the negative direction 2 for another point. And I can repeat that pattern going backwards. So really, it doesn't give me a different slope, it just gives me a different direction from that starting value. It still is the same line, just in a different direction. Oops. I can now connect those dots. And there we have our line drawn. So it's just going in reverse from when we were taking the equation from a line on the graph. We'll do one more example. So again, we have an equation y equals 3x minus 6. The minus 6 is our b value, which is our y-intercept. One thing to keep in mind, we want to take the sign in front. So if it's a minus 6, that means it's a negative 6 for our y-intercept. Our 3, that is our m value, or our slope, or rise over run, or multiplier. Again, many different terms for it. So we will be using the rise over run formula to help us graph it. So first things first, we want to graph our y-intercept, negative 6. So go to the y-axis, go down to negative 6. There's our first point. Next, we want to use our rise over run. Well, our rise over run is going to be 3. But wait, what's the bottom part? Where's my fraction? How do I turn a whole number into a fraction? Well, any whole number as a fraction is always going to be over 1. So anytime we only have a whole number as our slope, the denominator will be a 1. So this tells me then that starting from my point or my y-intercept, I go over 1 to the right in the positive direction, and then I go up 3 in the positive direction because I have a positive 3. That would be then my next point. I can then go over 1 again, up 3. There's another point. Over 1, up 3. There's another point. And if I start to see the pattern, I could probably fill out the other points without even using the rise and run. Now, there is a reverse to this as well. How can I reverse this fraction so that it gives me the same values, 3 over 1, but looks different? Well, similar to the last example, how we switched the fraction, here, if I, not switch the fraction, switch the negative, here, if I switch the signs from positive to negative, this gives me the same thing. Negative 3 divided by negative 1 is still a positive 3. So this helps me move in the other direction. I go to the left 1 because of the negative 1. And then I go down 3. And we should see that that gives us or creates a point that is on the same line for our linear pattern. So similar to how when we wanted to find or go back to a previous position from our patterns, we reverse the rule or reverse the multiplier. Same idea here. We're reversing the signs on the rise over run, which gives us the opposite direction. And there we can see we have our points, or our line. I'm going to draw arrows on the end. I don't think I did it for the last one, so I'll go back and do that, just because this pattern can continue on forever in either direction. Now, once we start dealing with word scenarios, obviously some will be more specific, or certain values won't make sense, like if we're dealing with time or height, or we may not have negative time, or right, things like that. But the main idea is being able to convert from a graph to an equation, and from an equation to a graph. So that hopefully, regardless of what representation or what visualization of our pattern or our rule or our linear relationship that we're given, we can come up with the other forms.